but I want to talk about exactly what I want to see on this, and I'm actually going to add to the directions because I want you to have a good preview of how a question like this would be asked on your assessment, okay? And we haven't really gotten a chance to see this question along with it. So let's look at number 46. Determine whether each function is even, odd, or neither, and then I'm going to insert these directions in there. Verify algebraically. Okay. Yesterday we learned how to test if something was even, odd, or neither. Now, with that being said, we also talked about a shortcut. And those of you that use the shortcut, that's awesome. However, if the directions include the statement, verify algebraically, I don't want you to panic when you get to that part. That was the whole plug in the negative x and compare your signs. But you actually got to show it. That's what verify means. If you go back to like pre-calc, you remember like proofs where you had to like show your steps. Okay, no, that was a bad example because now I just brought up bad memories, all right? But what I'm getting at is you have to show your work. That's what the word verify means, and trust me, it does not work. You can't just be like, because it's so. You have to like show the work. So let's look at number 46. Now let me talk to my little shortcutters. Is 46 even, odd, or neither? Odd. Good job. We remembered. Odd exponent, and that's all we have. If they're all odd, it's odd, right? But that's not verification. So I have said that it is odd. And now we're going to verify it. So to verify it, I plug in my negative x. It was f of x, right? Okay. I have to show this. It doesn't take much. I get that. There's not a ton you have to show, but there's like 2 lines you have to show. Plug it in, clean it up. Okay, that's what I need to see. This would be bare minimum of verification. This would stay negative because it's an odd exponent, so it would become negative 2x cubed. This would stay negative. Remember, order of operations, exponents first, then the multiplication. So this would stay negative because of the exponent. Multiply by the negative 6 would become positive 6x to the 5th. That would be your bare minimum of showing your verification. We took it a step further and set them side by side and looked at the signs, opposite, opposite, and that is a verification that it is an odd function. Questions on that? The mask is not staying very good. Was you either having trouble breathing? I got one of these from Amazon. Yeah, it makes me not eat my mask, but it's slipping down today, so I don't know why I'm messing with it. Okay, questions on that? Verify algebraically. Okay, with that being said, as we head into our last day of notes here, I will remind you hopefully at the end, but you guys do have a unit objective quiz on this on Monday, okay? So we'll come back. Something like me asking you to verify algebraically would be something that you would see on an assessment. That's definitely a normal thing to see on there, okay? And then, the second question, whether it is symmetric with respect to the x-axis, y-axis, y-axis origin or neither. That's where we again have to remember everything odd, right? Odd, opposite, origin, right? All start with an O. So we would say it's odd with respect to the origin is our symmetry. Any questions on even, odd, or neither? All right, let's go to then our last day on 1.3. 1.3 had a lot of stuff in it, didn't it? Man, we've been doing this for 4 days here. Okay, here's what you're going to be able to get done by the end of today. Today you're going to be able to use piecewise functions to graph them and to understand how to use them. And then we'll also find and simplify functions using this thing called the difference quotient. We'll look at what that is at the very end of today. You may have an introduction to piecewise function previously. There are a lot of different ways to attack this whole piecewise function thing. So there's not one right or wrong way to graph a piecewise function. We're going to give an example today of a method you could use. What is a piecewise function? A piecewise function is a function defined by 2 or more functions. Here is an example. A lot of times real world things have to be defined by piecewise because one function does not cover everything. So here's a real world example of a piecewise function. A telephone company offers the following plans. If you $20 buys you 60 minutes, and then after that you have to pay 40 cents per minute for anything above 60. Well, in order to draw to write a function for that, you would have to use piecewise because there's different like situations going on, right? And so that's what they're looking at right here, is that our function will be $20 if we use between 0 and 60 minutes. But as soon as I use bigger than 60 minutes, so t time being more than 60 minutes, now my function is going to cost this, $20, then plus 40 cents for everything over that, so our time minus 60 minutes. That's an example of a real-world piecewise function that you can see. And then those things happen all the time, right? You can, your price is whatever you bought plus shipping and handling, unless your order is over $50. So then you don't have to add the shipping and handling for something over that. That would have to be described by a piecewise function, because there's different situations going on based on how much you're plugging into the function. So real world, piecewise can be a nice thing because of different things that factor into things like your cost or whatever. This same function is going to show up on the next page. So those of you that are still writing, there it still is. Okay. Now, one of the how do we evaluate a piecewise function? First of all, remember that our function is of the format c of t, where t is our variable. So this is c of t. So in this case, our t is 30. And what you have to do is you actually kind of have to read piecewise functions like at the end first. You start at the end at the inequality. Okay, so if t is 30, I'm looking at these two inequalities. I've got an inequality up here that says 0 is less than t is less than 60, and then I've got an inequality here that says t is greater than 60. My t value right now is 30. It will only fit into one of those two inequalities. So if I put a 30 in there for t, see which one is a true statement. Is 0 less than 30 less than 60? Yeah. Glance at the other one. Is 30 bigger than 60? No. Okay, so it would only work in one of the inequalities ever. Okay, it'll never fit into more than one of those. Whichever one it fit into, so it works correctly in here when t is 30, tells me which function I'm going to plug that into. So I ignore the rest of this, and now my function looks like c of t equals 20, and I'm going to plug 30 into that. Well, that's kind of a weird statement because it's a constant. So I'm doing c of 30 equals 20. I would plug 30 into that function, but it's just 20. Okay, it's just a constant, which means our answer for this is 20. Questions on that? Okay, so let's try another one here. C of 100. So again, that's my t value. So t equals 100. If I come up here where there is a t, I put it in there and see if it's true. Is 0 less than 100 less than 60? Is 100 less than 60? No. If I put a 100 here, is 100 bigger than 60? Yes. So that tells me that for this particular one, we'd be using this second function. So my second function looks like 20 plus 0.4 t minus 60. And I would plug 100 into that. That might look familiar. That was one of our warm-ups actually a couple days ago. So if I plug 100 into that, and you guys type that into your calculator because that's not the type of mental math I'm trying to do today. How much does our plan cost? $36. Thank you. Okay. Don't forget this when we start looking at graphs as well. This is always an option if you have the function and you are asked to evaluate. Start at the end, the inequality. It will only fit into one of those inequalities. Plug it into that particular function. Okay? Now, ours happen to go in order. The first one went with the first equation, the second one with the second equation. That's just coincidence. Okay? It does not work that way usually, or by rule, okay? Okay, continuing on. Graphing a piecewise function. We're going to graph this piecewise function, and we are going to just graph it by putting a table and plotting points. As I am doing this, please make sure that you make notes for yourself as to why I picked the numbers I picked in these tables. Okay? And there's a very specific reason I'm picking the numbers I pick. So we have 3 different graphs that we are going to be graphing. I'm going to look at this first one first. Our first function is 3 if x is less than or equal to -1. Okay, so my first function says that we're going to graph the function f of x equals 3. I'm going to make a table for it. And the thing that people forget is, how do I pick the numbers for my table? Start here. Now, I don't care if it says or equal to or not. You start at the number you see in the inequality, always, okay? So I see the number -1 in the inequality. That is going to be the first number in my table. And then I start filling in my table based on the inequality. It says x is less than that. Okay, so then I start picking numbers that are less than -1. Numbers that are less than -1 would be like -2, -3, -4. There is no set number that we need to pick because there's x numbers continue less than -1 to infinity, and we're not going to write out to infinity, right? I would pick 3 or 4 until you feel comfortable that you see the shape of the graph. This would continue. You will see the same notation on mine all the time. I put an arrow down here because it was just less than. So it could have continued forever that direction. I could have made my table like super long, right? On the other end will be a dot. This tells me what kind of dot I'm going to draw. So just a quick reminder, when doing dots, if it is a less than or equal to or a greater than or equal to, your dot is filled in. If it is just a less than or just a greater than, your dot will be open. Ours was or equal to at -1, so I will have a filled in dot here. And I just marked that on the side, that is for my own purposes here, to remind myself what I'm going to draw when I get over to the graph. I now start plugging them into the function, and this one's a weird function. When we are a constant, when I plug -1 into that function, I still get 3, right? Kind of like we talked about on the last page. When I plug -2 into that function, I still get 3. When I plug -3 into that function, I still get 3. When I plug -4 into that function, I still get 3. Anytime, a little helpful hint, anytime it is a constant, your graph looks like a horizontal line at that number. Okay, so let's go graph those. So at -1 up at 3, I already discussed this, but we're going to put a closed dot because of the or equal to. And then we've got points at -2, 3, -3, 3, -4, 3, and it continues as a horizontal line in that direction. Every single part of your graph has to have either an end of dots or arrows. You're not just going to have some line hanging out there, okay? So you'll finish each picture you draw with dots or arrows. And then we move to our next function. Okay, remember the inequality is going to tell me what numbers to put in there. If it's a 2-ended inequality called compound, it tells me where to start and stop. So then I just follow that. Start at -1, stop at 2. Okay, now the order that you put those in there actually really does not matter. I usually start with the smaller one, -1, 0, 1, and 2. At -1, we've got a less than symbol. Open or close dot? Open. At the 2, we've got the or equal to, which means close dot, right? The opposite. Questions so far? Good? Okay. So now I'm just plugging these into my function. I'm going to take a -1 and plug it in for x. -1 minus 2 would be -3. Yeah?
Isn't it 0, 1, 2? Because it's
You're going to still put the number there, and then I'm just going to indicate that it doesn't equal that by putting an open dot there. Does that make sense? It's not included, but we're going to get really close to it. Like I can put negative 0.5 in my picture because that heads to it. So I will put that number in the table even though it doesn't equal it. And I just indicate that it doesn't equal it with that open dot. Great question. Continue plugging these in. 0 minus 2 is negative 2. 1 minus 2 is negative 1. 2 minus 2 is 0. There's 4 ordered pairs for me to graph this. If you step back and think about algebra, you might recognize that this was a linear equation, right? Y equals mx plus b. So I would expect a straight line from these points. Open dot at negative 1 comma negative 3. And then dots at 0, negative 2, 1, negative 1. And then a closed dot at 2, 0. Closed, connected with a straight line. Now, I have some people out there that draw super, super tiny. That's fine, but you have to make your closed or your open dots obvious. So if you are somebody who draws super tiny, just make sure that your open dots are obvious, okay? And then we move on to our last function. Again, if you happen to know something about the shape of that function, we haven't really talked parent graphs, but does anyone know what shape an absolute value is? A V, right? And so a lot of times you're going to expect to see that shape happening in wherever you are graphing it. And if you haven't seen it, I would pick another point, and I'm going to show you a perfect example of that on this particular problem. Absolute value of x minus 4. Again, I'm going to set up my table according to this number. I know it does not equal 2 because it doesn't have the or equal to, but that's how I start my table. And I just indicate that it's not actually going to equal that value by putting an open dot for that particular one. Okay? So start my table here, right? And then I continue bigger numbers than 2. So like 3 or 4. And again, everyone's like, how many do I pick? Well, I want to see the shape. And I'm going to stop there for just a moment as a point. Remember that if there's not a dot on the other end, it's going to be an arrow. Now, if I only pick these 3 points, I want to show you what happens. Plug 2 in here. 2 minus 4 is negative 2. Absolute value of that turns it back into 2. You got it. So I would have a open dot at 2, 2. Plug a 3 in there. 3 minus 4 is negative 1. Absolute value turns it into 1. And plug a 4 in there. 4 minus 4 is 0. Absolute value is 0. Now, if I were to stop there, it looks like it would just be a straight line, and a lot of people would continue a straight line down this way. But if I pick one more point, and I plug it in there, 5 minus 4 is 1. Absolute value is 1. It rebounds, and that's where the V happened. If I didn't pick that point, I would not have seen that shape. And so anytime it is an absolute value, these are the two that this always happens on. Absolute value and parabolas. And if you don't see the V happen or the U happen for a parabola, pick one more point. Got it? See the shape. Okay, there's our picture. That was the first thing I asked you to do. And then a lot of times this is comboed with evaluate questions, and people forget what we just did on the last page. I can look at the graph for these answers, or I can just do them like I did on the last page by plugging them in. So if I then asked you, okay, take this and evaluate for f of negative 2. Again, 2 different ways I could do this. I could look at the picture. Or I can do this like I did on the last page, where I say, okay, if my variable is negative 2, which of these does it fit into, right? Is negative 2 less than or equal to negative 1? Yes. So it tells me that I would use that first function. And if I plug negative 2 into 3, don't I get 3? Okay. You actually did that right here. We plugged negative 2 into that function, didn't we? So if you have your tables, you can actually just find the values already over here as well, assuming it's one we plugged in. F of 0, again, I come up here, is 0 less than negative 1? No. Is 0 bigger than negative 1 but less than 2? Yes, so that tells me I would be plugging it in here. So I would have used that second function. I would plug in a 0 and get an answer of negative 2, which again we already did right here. So you can see it matched our answer. I can also look at the picture. If my x value is 0, finish the ordered pair 0, comma what? -2. All tied together. It's all the same thing that we're doing. Okay. Last one is 3. You know what? I'm going to change that. Let's change the last one to 2. We need to have this conversation because we have not had this conversation yet. Okay. Erase all this up here. Okay. They will almost always, when evaluating a piecewise function, ask you one of these tricky ones where it will be where you flip between two equations. Do you guys see what I'm talking about up there? I see 2 twice up there, and I have to figure out which of these is a true statement. Does 2 work here or does 2 work here? And it 100% comes down to the or equal to or not. Okay? So if I put a 2 here, I'm going to pick the one that's false first. Is 2 greater than 2? No. Okay? Is 2 less than or equal to 2? Yes. And they will almost always ask you one of these where it flips between the 2 equations. So you have to slow down and find the or equal to guy. And so I would plug it in again to that second function. And some of you are going, wait, we already used the second function. Guys, there's no like set number of times you would do this. I can use the second function for all 3 of those questions if they all fit into that inequality. Okay? Any questions on that? All right. I got to answer a 0. Okay, the last thing we're going to talk about today is this difference quotient. And this one I found was a very interesting. I told you we were going through new books this year, right? Our old book did not address this whole difference quotient thing. I find it very fascinating because if you move on to a calculus course after this, you're going to use this difference quotient that looks just like this all the time. It is like the foundation of some important things in calculus. So I thought it's a great preview to those moving on to calculus, but it also just helps us with our algebra skills and evaluating functions. So the difference quotient is this. It's got x plus h and x and h, and we have this whatever function will be written up here twice. The first time we evaluated at x plus h minus the second time we evaluated at just x. And we're going to talk about some things that will always happen when evaluating your difference quotient, is that it will always simplify down very, very similarly. It's the algebra that gets a little ugly on our way there, okay? So, to prep for that, let's talk about evaluating a function at x plus h. That's like this little part of it. So we're just looking at this first piece, because sometimes it gets a little ugly when doing the binomial x plus h in there. So we're going to do just that piece of it. So if our function is -2x squared plus x plus 5, and I ask you to evaluate that function at x plus h, remember how we attack something like this. Is I'm going to write out this function, but everywhere there's an x, I'm going to put in a parentheses to just leave a space for what I'm plugging in, right? So I've got -2 x squared x plus 5. And they are specifically asking me to evaluate this at x plus h. So everywhere there was an x, I'm going to fill in an x plus h. And then we clean up as best we can. I will tell you on the difference quotient when it's at x plus h, it's not going to clean up very much yet. It will eventually. It's kind of ugly. Remember that this means FOIL, right? So I'm going to write this twice in FOIL. And the whole foiling of an x plus h is a little weird and ugly. But I would get x squared, x times h, and x times h would give me 2 xh's, right? And h times h is h squared. Did I do that too quickly? I'm not really showing my work on that. Are you okay? This is the one I'm worried about. We all know where I'm getting 2xh. That's my outsides and insides. Same term, which means there's 2 of them, right? I would distribute whatever number is here, but it's a 1, so it's not going to change anything. I do need to distribute the 2. Okay. Yeah. Darn it. you. We would have gotten so far into this, and I would have had a... There we go. Okay. Any other mistakes I made? Okay. Hang on to that. I'm gonna switch pages, but you guys should all have that on your page right now, right? What you just did was the first part of this, so now we're going to do the full-blown thing. I'm giving you the same function at the top, okay? So what we're going to do is we're going to evaluate it for x plus h minus evaluate it at x, okay? So we will do that function one time minus do the function a second time. This will be our evaluating at x. This will be our evaluating at x plus h. Okay, now typically we would have to do the work, but we just did this on the last page, didn't we? So I'm just going to transfer our answer to this, evaluating at x plus h, into here, which was negative 2x squared minus 4xh minus 2h squared. And you're going to double check that I write this correctly. Was it plus h plus x plus h plus 5? Okay. And then I do it a second time evaluated at just plain old x. Well, guys, this is f of x evaluated at plain old x, isn't it? So it's going to look just like that. But I will tell you, you have to have the parentheses. Very, very, very important that you put your second one specifically in parentheses. The bracket on the first one, not a big deal, but I wanted you to see the separation. Okay, why am I saying that that's such a big deal? What would be my next step? I have to distribute the negative in there, don't I? Okay, and if I don't put those parentheses, I bet you I'm only putting that negative on the first term and not remembering that it has to go all the way through. So super, super important that I remember the brackets or parentheses. I use brackets for some reason. I guess today's a bracket kind of day. Okay, but I have to distribute that negative through, and that's very important because it's going to make this clean up super nice, and I will tell you that these next two steps will always, always happen. They'll look a little different per problem, but the result will be the same, okay? So if I do that, I'm going to switch colors here just so you can see my second function. A negative times a negative would be a positive 2x squared minus x minus 5. Okay, here's why it is so important that I distribute that negative, because at this point you should have some things canceling. You will always have some things canceling. Negative 2x squared and positive 2x squared. Gone, right? And negative x and a positive x. You kind of got to search for them a little bit, but that's gone. Positive x, negative x, gone. What else can I get rid of? 5. Positive 5, negative 5, gone. Now, this is a great note for your notes right here. If you do this correctly, what is left over should all have an HGCF left in it. Let's look at what we have left over. That's got an H, that's got an H, that's got an H. Okay? If I have done this correctly, everything that is left over should have an H in it. It should be my H terms. So what do I have left over? 4xh minus 2h squared plus h over h. Why is that such a big deal? Because I can now simplify. GCF at this point, specifically of h. They all should have an h in common. So I'm going to factor that out. If I take an h out of each of these terms, I'd have a negative 4x. I'd have a minus 2h. Ooh, if I take an h out of h, what do I have? 1. Good thing I asked, right? 1. Because if I were to distribute this back through, I need it to be back this, and so h times 1 would give me that h there, but h times 0 would not, right? Why is this important? Because this happens now. Every time if I did this correctly. HGCF, every time if I did this correctly, crosses off here, which will leave me with negative 4x minus 2h plus 1. Now, I am not going to ask you to do a lot of those. I get that that's a lot of work. And if you ask my calculus kids in about 2 or 3 weeks, they're going to hate this because they're going to have to do it a lot. And eventually never again. But it's very important for them. So, questions for me. Again, highlight the things that always happen. This always happens. Simplifies down to just terms with h's. Should take out the GCF. Simplify with the h in the bottom. You should not end with a fraction. That h should go away. Okay? All right. What are we at for time here? We're sitting good for time today. So let's grab our dry erase markers, please. Got my fancy new safety goggles. You can get the virus through your eyes, and so if we are within anywhere close to you, we have to wear, well, we had to wear our shields, and then they, like, I couldn't see because my shield was fogging up so bad, right? So then the district came back and said that we're allowed to wear safety goggles or safety glasses, so you might see teachers walking around with these. These are supposed to anti-fog. They do a little bit, but I can at least now walk around and, like, see your guys' work. Oh, well, that's not. Okay, on the board. Let's go. You got 3 problems. F of 2, F of 0, F of 3. Do not graph this. Do not graph this one. And you don't have to fill in the whole table. You can just do that one. So we would just do, you don't need to do all the rest of them. If we were graphing, we would need the table. Looking good, guys. Looking good. Looking good. Keep working. You do not need to do the whole table. Do specifically that one, so you wouldn't have needed those two. You're just doing too much work. Just do the one value that they're asking for in the correct function. You know, it all looks good, guys. Yeah. Wait till she gets back. Okay, just to point out, I know we've kind of attacked piecewise functions in 2 different ways. We were graphing them and we were evaluating them. I kind of caught a couple people doing too much work. It's not that you're wrong. We just don't need that much work if the only question is to evaluate it. Remember, I'm just saying, okay, if my x value is -2, which inequality does that fit into? Well, -2 would fit into the top one, is less than 0. So I would pick this, f of x equals 3x plus 5 as the 3x plus 5 as the function that I would plug that into. And then I would evaluate at -2, which is -6 plus 5 or -1. I told you they were always going to ask this one, didn't I? At the place where it switches between the two, so you have to slow down. Is 0 less than 0? No. Is 0 greater than or equal to 0? Yes. That tells me I would pick that second function as the function that would be appropriate for this one. Plug in 0 and get an answer of 7. And on our last one again, 3 less than 0, no. 3 greater than or equal to 0, yes. So that tells me again, of those options up there, I would have picked the second one. Plug in 3. 12 plus 7 is 19. Okay, graphing this one. Give you some time to graph this one. can grab you a little. You got this right here. Just graph it on the graph. Yeah, just graph it on a graph. Don't worry about the negative infinity to infinity. That just means on however you draw your graph, draw this from left to right. I mean, draw it like you would normally draw a graph. It does not change anything. Which is why we do this, so that if we run across these directions that we're not going to like panic and not know what that's asking. It's just saying that your domain is unrestricted. Graph this, please. Now, once you're done, notice there is actually a second question up there, and it asks you to describe the range. That's a great question for this one. Okay, so we'll talk about the range on this. Tables, remember you're going to start at the number you see, decide open or close dot, which way are we picking numbers? So you would put -2 as your first number, and then in the X, yep. And then now the first one says numbers that are less than -2. What are numbers less than -2? Yeah, so for that first graph, you're going to pick -2, -3, -4. Yep. If there's not two numbers to your inequality, then the other end is an arrow. So like if it had said like 0 is less than x is less than 3, you have 2 dots because you'd have a dot at 0, a dot at 3. But if they only give you one number, the other end is an arrow. All right, I'm seeing some great stuff as I walk around the room. Think about what you would answer for part B. How would you describe the range of this function? And it is tricky, but the answer is not, but the thinking about it is. Yes. I like that second question, the range part of it, because it makes us think about, remember range goes lowest point, comma, highest point. Regardless of the symbol, I start at the number I see in the inequality, right? So my very first number is going to be a -2. Because the symbol is just a less than, it's an open dot, and I have to pick numbers less than. -2 to fill in the rest of my graph here. If there is not a second number, that graph is going to be on the other end an arrow, because it would continue. Plugging that in, -2 plus 3 would be 1. -3 plus 3 would be 0. -4 plus 3 would be -1. So we start at -2, comma 1 with an open dot. -3, 0. -4, -1. Arrow. You have to have both of those on there. Dot, open dot, arrow. Second one. Here's my function. Again, my table starts at the number I see here, which is -2. Because of the or equal to, it'll be a closed dot. I'm picking numbers bigger than that, like -1, 0, 1. Arrow in that direction as well, plugging them into my function. -2 minus 3 would be -5. Negative 1 minus 3 would be negative 4, negative 3, negative 2. Didn't give myself enough room here, so negative 2, negative 5. Closed dot. Negative 1, negative 4. 0, negative 3 here. Arrow on that end. Let's see if we got the correct range. What is the lowest point this graph would go? And my picture does not, is misleading to this answer. What is the lowest point this graph would hit? Negative infinity. This arrow right here would continue down forever, wouldn't it? That's tricky because this looks like the lowest dot. Your range is negative infinity. What's the highest dot? Infinity, again, tricky because this looks like the highest dot, but it's not, right? Because this arrow says we're going to keep going up forever. You got it. All right. Last one. Last one on your table today. Try out your difference quotient. I can help as I walk around here. Remember, your x plus h is what you're plugging in first, and then x should just match whatever the function was. Don't forget your parentheses. Don't start at the bottom of your table. You're going to need a little bit of room.
Is it always going to have the h?
It is. Yep, it'll always match that format right there. Your function is x squared minus 4x plus 3. Evaluate it the first time, plugging in x plus h, minus evaluate it the second time, just plugging x. You guys need to learn each other's names. Be friends. This might help. Remember, you are writing out the entire function the first time, evaluating for x plus h, minus write out the entire function a second time, evaluating for f of x, just at x. All over h. Absolutely. What'd you get? Yes, you're doing. I feel like you're missing a number though. What number are you missing? You lost some term. What did you? I think you foiled from your top line to your second line. I think you lost your XH term. This one right here should be a 2XH. Does that make sense? Okay. All right, guys, I know that this is a challenging one, and there's a lot of algebra to show at the beginning. So hopefully, again, my visual up here can help. I am writing my function out. My function is x squared minus 4x plus 3. I am writing this out, putting in parentheses everywhere there's an x, right? So it's going to be x squared minus 4x plus 3, x squared minus 4x plus 3, and then you just specifically plug in whatever they ask you to evaluate the function for those different times. The first time, you are evaluating the function for x plus h. So in each of those openings, I would put in an x plus h. The second time, you are evaluating the function just for x, which ends up looking just like the original. Okay? And then it's the whole cleanup process. Write this twice in FOIL gives us an x squared plus 2xh plus h squared. Distribute the negative 4 through, minus 4x minus 4h plus 3. My second function, I have to take this negative and distribute it through to all of those terms. Remember, this should simplify nicely to only things that have h's left in them. X squared minus x squared is gone. Negative 4x, positive 4x, gone. 3 minus 3, gone. And what I have left over, all have h's, not by accident. Because now I can take out my GCF of h. And cross it off with the h in the bottom. 2x plus h minus 4. Tricky, yeah? Those ones are tricky. All right. You are on assignment 8 on my math lab.